Hi folks! Welcome to this unit on graphing. This unit is specifically designed to help you better understand what a graph is and what it is not, how to make a better graph, as well as what the actual real purpose of graphing is, other than just simply to draw pretty pictures. First of all, a graph is a visual representation of a relationship between, but not restricted to, two variables. By relationship, I'm talking about how they interact with each other. So let's start off with the parts of a graph. Now, this is not representative of every graph. However, nearly every graph that you're going to be running into is going to have an origin. You can see right here that we have our marked origin. We also have our y-axis and our x-axis. Some important things to note is that you need to make sure that your labels on all of your graphs are accurately reflecting the data that you're showing. So what does a good graph have? First of all, a good graph needs to accurately represent facts. Oftentimes in the media you will see graphs which are skewed to represent what the publisher wants to have shown. A good graph should accurately show the facts. Now, also a good graph should complement or demonstrate the arguments presented in the text. If you're talking about velocity in your text, having a graph that talks about position or acceleration might not be the best position for it. It also must have a title and labels. In truth, if a person looking at your graph does not know what they are looking at and know what your variables were, it's nothing but a pretty picture and does not actually add to your data. It needs to be simple and uncluttered. If it is complicated to read a graph, most folks are going to avoid it. You need to show the data without altering the message of the data. Now let me give you an example of that. I have seen graphs where across the bottom they have had dates, and at the very beginning of the graph those dates were numbered out in like 1915, 1916, 1917, and then without making any adjustment they shift to 1960, 1970, so changing from going single years to full decades, and then even shifting out further than that. When they put the rest of their data points on, it appeared that they had created a linear relationship, a straight line. But if you actually stretched out the data points, it was not that simple. Now, the reason that you want to not alter the data is so that it clearly shows any trends or differences. Now, when should you not use a graph? If your data is really dispersed, for example, you have 1 or 2 points in one area and you don't have a lot of data until another area further away, there are better ways of representing that information than in a graph. Also, if you only have 1 or 2 or 3 data points total, a graph might not be the best way. A table might be a better way of showing this, or even just simply describing your information in the text. Now, you should also not try to use a graph if your data is extremely numerous. Try and take a look at this particular graph. You have got rate and year and multiple languages all combined in this particular graph. What, in your humble opinion, do you think would be a better way of representing this data? Some suggestions other students have made would be to separate it out into different graphs with fewer of the languages involved. Other students have suggested that putting that data into a table or a different kind of chart or graph might be more useful. Now, what is the message? Remember, your graphs are telling stories. They are telling information that adds to your understanding. So, if your graph is going to describe components, you should use these terms in your text. Share of, percent of, the smallest, the majority of. If it's going to compare items, then you need to give your comparison terms: ranking, larger than, smaller than, equal to. If it establishes a time series, then talk about change, rise, growth, increase, decrease, decline, or fluctuation. If it determines the frequency, then talk about range, concentration, most of, distribution, etc. And if it analyzes relationships, which is mostly what we are going to be doing in this class, you should give comments like increases with, or decreases with, varies with, despite, corresponds to, or relates to. All of these terms indicate or show a relationship. So what types of graphs are available? Well, I know that you've all been studying about this since you were in elementary school, but let's go over some of them. First of all, you might find a pie chart, which is really useful if you're going to be describing components of a particular thing. If you're looking at parts of a whole, a pie chart is an excellent way of representing that. A horizontal bar graph or a vertical bar graph are very good for showing comparisons of items and relationships or a time series. A vertical bar graph is also very good for showing frequency distributions. Now, if you need to show a time series and frequency distribution, a line graph would be more useful. But if you're looking for relationships, the scatter plot is your very best choice. All right, pie charts. Pie charts use percentages to compare information. These percentages are used because they're the easiest way to represent parts of a whole. You construct a pie chart by converting the share of each component into a percentage of 360 degrees. Bar graphs show quantitative relationships between two groups of data. They oftentimes show trends and preferences. Now, line graphs are the ones you see almost more commonly than any other. They are very popular because their visual characteristics show data trends very clearly, and they're very easy to make. They're especially useful in the fields of statistics and science, and are one of the most common tools used to present data. A line graph is a visual comparison of how two variables shown on the x and y axis are related or vary with each other. Now, the scatter plot. This is commonly used in science to present measurements of two or more related variables, or at least two variables that we think might be related, because when we put it into the scatter plot, we can clearly see if a relationship exists. They can be used to illustrate relationships by data correlation, positive or direct relationships between variables. That means as one increases, so does the other. Negative or inverse relationships between variables. As one increases, the other decreases. Scattered data points showing no correlation. Nonlinear patterns. Spread out of data, and it's really good for helping us to identify those outlier points that are outside of the norm. So let's talk about what I mean by data correlation. You'll notice with this particular graph over here, we show a positive linear correlation. You can see the data points as variable 2 increase, or variable 1 increases, variable 2 increases also. Here, as variable 1 increases, variable 2 decreases. This would be called a negative correlation. So here is a positive correlation. Here is a negative correlation. Now this one would also be another positive correlation, but you can see your data points are a little bit more scattered out. This is what is called a best fit line. It tries to take all of your points and says if in an ideal world everything lined up, this would be the line that best fit this data. Now this one here shows no correlation. You can see that as variable 1 goes up, it has no reflection on what, or no predictability on what variable 2 will do. So, what about this one? What do you think? Is there a correlation here? Isn't there a correlation? Is it positive or is it negative? Some of you may have agreed with me in saying that it appears that there is a weak correlation between these two variables. So we've now been comparing force and acceleration to see if there is a relationship. Now, if I were to give you a set mass of 100 kilograms, and you were to use the following data and graph it by looking at the acceleration of these different forces, I want you to determine if there's a relationship. After I finish talking, I want you to pause here and I want you to go ahead and graph out this information. So, set your force, set your acceleration, and then I want you to graph your data. Go ahead and pause now. All right, is this the graph you came up with? Notice that the force is on the bottom. That is your independent variable. Acceleration is on your y-axis. That is your dependent variable. As the force increases, so does your acceleration. Acceleration depends upon the force. You'll notice that it has each of your data points falls in a predictable line. This shows a positive correlation between acceleration and force. The slope of that line will tell us some special information. Now, interpolation and extrapolation. We use graphs in order for us to predict things. Interpolation means finding a data point within the data set. Extrapolation means finding a data point outside the data set. So what I am talking about, taking a look here, if I had a force of 25 newtons, I could interpolate what the acceleration would be because I am looking in between two known data points. Extrapolation would be looking at a point out here, following this line out, saying perhaps with a force of 200 newtons, could I predict what that acceleration would be? Now, which will give you a more accurate value? Interpolation will, because you know there are set points on either side, limiting the degree to which you could have error. Now, we are going to be looking at finding relationships. So when you come in tomorrow, be prepared to answer some questions about graphing and learning more about relationships in graphs. Thank you.